So, hello and welcome everyone who is joining today's webinar to see how to solve the tasks published by WU, very kindly of them. And actually, I've never seen this generosity before, ever in my life from WU, because when we were doing our exams in 2019, we didn't have anything. Basically, we weren't provided with materials or nothing like that. So it's very nice that for your year, they decided to publish a bit more so that you're more or less aware of how and what to prepare for the math part. They haven't published all the tasks, there are 8. There should be 13 tasks in total when you when you solve the whole thing, so to say. So some things are left out, like differentiation topic or a measure probability topic. Not sure why. Maybe they just want to show the full thing, just kind of still keep some element of surprise for you. But still, with the 8 tasks that are published, it's very, well, it's nice, right? So yeah. Then to find the link to that file, I'll also send it into the chat, and I will also publish the link after the recording has been done in the description of this video in case you're looking for it. And there's also a similar file for WiSo. So they have published around, I think, 6 tasks for WiSo for the math part in German, also in the exam section of the entrance exam for the German bachelors. So yeah. And then I'll just send it in the chat in case someone couldn't find the file for the tasks themselves. It's in the entrance exam section of WU. And I've made the solutions. They're also will be published as a file for you to check out later. So don't worry, you will not, like, after this is done, you will have the recording and you will also have the PDF version of them for you to solve them yourself and then for you to look at the solutions later on. So let's start with the first one. We have the logic task first. And throughout the years, they've been changing the tasks a bit. So for example, in 2024, the task was still more or less one theme. So there was one big theme at the beginning, let's say a party task where people are attending or not attending, depending on who else is coming. Yes, the session will be recorded, will be posted. And then I'll just close Instagram so people don't disturb us. So now they have decided to switch things up a bit and make them a tiny bit more challenging for you, where each statement is a separate task of its own, so you have to spend time separately on them, and they're not interconnected between each other. And there's actually some very nice statements. Honestly, I respect to the exam makers. I recognize the craft when I see it. So here we start off nice and easy. So if we have an application that every mathematics student can solve equations, we say M, therefore solve. So mathematician, therefore solve. You can name it with any letter that you like. I use M and S just to kind of refer to the initial statement. Then is equivalent to the statement if a person cannot solve equations, therefore he or she is not a mathematics student. So the contrapositive statement would be switching them sides, like you switch places, and then you would have, it's actually equivalent to that. But the way this works is that in logic, you have something called the necessary condition and the sufficient condition for each other. In an application, the first one is sufficient for the other one, and for the right to left direction, it's necessary. So solving equations is necessary to be a mathematician in our case. Of course, like, don't try to think of them like in real life scenario. Think of them with logical rule scenario because this is a math task. This is not an economics task. So here, we would say that if we just say no maths, therefore no solve, this would be wrong. This is not correct. You cannot say this because it doesn't matter if this. So being a mathematician student guarantees that you can solve equations, but you can solve equations for other reasons apart from being a math student. So if the math student doesn't happen, this is not affected by it. But if we do the other way around, where S is a necessary condition, so if you don't solve, therefore not a mathematician, is true because solving equations is necessary for being a mathematics student. So here, this one guarantees this, but it's not necessary. I like to do this little scheme. And here it's necessary, but doesn't guarantee it. And therefore, if the necessary condition doesn't happen, so that's why we switch the places in the no part. So no S, therefore no M would be correct because if the necessary condition doesn't happen, the condition that it's necessary for also doesn't happen. If you have questions as we go, please let me know in the chat or by unmuting yourself. Oh, it's now 70 people. Wow. 71, okay. Then here we have something called with the negation of the implication. This is a tiny bit different. So you have a statement, and they say that this part is the negation of the following implication. If the sun shines, we will have lunch outside. If you wanted to negate the whole implication, like the whole statement together, not the contrapositive principle, but the negation of the statement, it's slightly different. There are slightly different logical rules for this. Here you would have, okay, sun shines, lunch outside. So the original one that we're trying to test is there is sun, we will have lunch. And to negate it, you would have, okay, we say this just means no. It's just like a logical sign. Just for my notes, it's a bit neater to do it this way. This is a logical rule. If you want to negate a statement in this form, you would have the following. So sun shining and we are not having lunch outside would be the negation of this. So sun shining, and this is an and sign, us not having lunch. Lunch would be the negation of the original statement. And this is not equivalent to the given statement. No sun, no lunch. Therefore, it's false. Because this doesn't match with what is written here. So if you're new to logic and you haven't had it in school before, please look up the logical rules, how the implications work, how logical equivalences work, how negations work, and contrapositive principles work, because this will be useful for these tasks. You can technically sometimes answer them logically as well, without knowing all the rules, but it definitely helps to be more confident when you know the rules. Then here we have, so you immediately say, okay, we would have to do substitution with t. So t is equal to x squared and is greater or equal to 0 because x squared is only positive or 0, it cannot be negative. So here we have the fact that, okay, we solve the whole thing for t. So we substitute where it's going to be t squared, then plus 8t plus 15. This is our new parabola. And we want to find such a part of it that will make it negative. So if it's a concave parabola and we have two roots, one of them being -5 and one of them being -3, it is negative in between the roots and positive outside. We want the negative part. And this inequality, this is gonna what's happen. So t has to be between -5 and -3. But we mustn't forget that whenever we were doing a substitution, if it's x squared, if t is a number squared, t can be negative. It's not possible for a squared number to give you a negative result. Therefore, there is no real solution there is no real like the t there, yeah, there is no real t that satisfies what we want to happen. So it actually is a case where you have a logical equivalence where both of them are false. So this is false, there is no solution here. And x squared cannot belong to -5 and -3 because x squared can belong to negative set of numbers. So when a logical equivalence is both false on the same side, it's actually true. Because for logical equivalence to be true, it's either you have true and true statements on either side, or you have false and false statements on either side. A lovely statement, I would say. A relatively niche rule in mathematics, but here it was necessary. But also just logically by looking at it, like, yeah, like it's likely to, like, this thing doesn't work, this thing is also weird. So they're both false and false, therefore the overall thingy is true. So be careful here. Because otherwise you might just say it's false because it just doesn't work, but we're dealing with two falses on either side. So if a natural number x is divisible by 3, then it is divisible by 9. If you find just one example for this, where it gives it as a false result, it's not possible to do that, then you can say that the whole thing is false. just by finding one counter example. So let's say number 3 is divisible by 3, obviously it's like 1, but it's not divisible by 9 because it will not give you a whole number as a result. So therefore this whole thing is just false. I think this is relatively nice and simple. And statement E, so x is divisible by 12 and x is not divisible by 11. It's true for every positive integer multiple of 24. So is it really true for every? Not really, because again, if you want it to be divisible by 11, the first thing that you can think of to get the multiple of is do 24 times 11, right? Because that's going to be guaranteed divisible by 11 because this is like the harder thing to find. Because divisible by 12, it's relatively easy for 24 to find such numbers. But by 11, you just go straight into 24 times 11. So this is a positive multiple. So the multiple is this result. So you do 24 times 1. So 24 is a multiple of 24. 24 times 2, 48. 48 is a multiple of 24, and so on and so forth. So 264 is a multiple of 24 when you're multiplying it by 11, which is a positive integer number. And then it also happens to be divisible by 12. Gives you 22 without any remainder. So therefore this is false. There is such an example where it is divisible by 12 and also divisible by 11. But these statements were done relatively short, like a short description for me to explain it on the video, because now you can kind of hear me explaining, it's fine. But I will also make them a bit more longer and detailed for the people I'm publishing it for on the website, because I will do it in the blog section of my website as well, as to save them there. So the correct statements are A and C. And when you're solving this part of WU, you can also double check if you want. You can go down the statements, like at the very end, and see the right answers. Another important note that I would like to mention on this file is that I've also received questions about it. This is the formula sheet. As you can see, not very detailed. Like I've told you in one of my previous reels that it's not going to be really, really helpful. It's just like how they disseminate, blah, blah. But basically, at least one correct, right? At least one assertion correct. Because before, in the WiSo platform, in the online platform, you had true or false, like this. And then you could choose all true or all false. You can get some partial points and so on and so forth. And your strategy was never to leave anything blank because you would get 0 points for leaving something blank and some partial points if you at least get something at least partially correct. But now WU is trying to prevent you from basically guessing and getting any like lucky points. There's no lucky points this year. Because here you have the boxes, B, C, D, E. And they're trying to prevent the fact that if you leave it all blank, assuming everything is false, you get 0 points. Because you didn't get any correct answers. You didn't choose any correct options, therefore you get 0 because you didn't choose anything, right? So yeah. And that's why also if you crossed all of them out, and some of them were right, let's say A and C were right, and you got like some plus, I don't know, 2 points and plus 2 points out of, I don't know, out of 4 or 5, doesn't matter, or 3, depending on like the number of points you have. But then you have minus, and then, I don't know, minus, and then -2, for example. They will weight the minus and positives differently, depending on the question, the number of correct solutions, like the number of correct statements and everything. So they're just trying to prevent if you also just cross all of them out, you also get 0 points. So there's no guessing available because if you leave it all blank, 0 points. If you cross all, 0 points as well. Of course, all of them could be true, but if you do this for every statement, you're just going to be losing points. So yes, there is a possibility that all answers are correct. But for most questions, if you do something like this, if you cross all of them, you will very likely just get 0. Maybe there is a possibility to get partial points if the negatives weigh a bit less than the positives, but let's see. For my year, they actually just published the partial point grading system explanation on the website as a link. So once that is published, I will also let you know as soon as I know.
Wait, but do we get negative points if we guess one or two wrong, or just if we cross out everything?
You also get negative points if you guess something wrong. Let's say you can also just not cross this one, but you still get -1 and -2 for these ones. You just get less minus.
Yeah, okay, thank you.
So the lowest you can go is 0. So at least there's no negative points for the whole question. But even if you don't guess, you can still get some negatives. So you get 0 here, and then yes, it's better to be blank rather than choosing wrong. So that's why this year is as important as ever that you study, so that making educated guesses is a bit better than just guessing. So if you like have a feeling for okay, it's more likely to be true, more likely to be false, you will more likely get the point for that. This one, some things look scary, but they're not. And always pay attention to the definition. So for example, X, Y, and Z are real numbers, including 0, right? But here, they say that Y isn't equal to 0. This is the only reason you can just cancel it out eventually. So these statements where it's not equal to 0 or it's not equal to minus plus minus 1, making it 0, are the only reasons you can actually cross them out so confidently. If there is no such point where like y is not equal to 0 or something like this, and you say y is a real number including 0, then you cannot do this, what we're going to be doing here with the simplifications. So really be careful with the definitions. They are there for a reason, like it's not just like fun facts. So here, okay, this is just you're just messing up, not messing up, but you're messing around with the what you can cancel out and how. Not too much to do here. Like this is 8y, this is 4 and y squared, because if you square it, you get -2 times -2, you get 4. Y squared is y squared. And then you get 2 over y and not -2 over y. A good question, yes. But you have the inequalities. So you could, yes, there were some annoying inequalities in one of the previous years, like really bad ones. Yeah, because in 2024 I made an extra task for the course with updated versions for the logarithm, like for the irrational inequalities and the absolute value inequalities based on the previous year, 2023. But in 2025 they made it more text-based. So the inequalities task that we will see later and the language algebra task that we saw now is arguably a bit easier if you prefer text over solutions or like over solving an equation. Because some people just prefer solving it and it's easier for them. So yeah, but subjectively, yeah. So then here we're just messing around again with a bunch of fractions. So we're multiplying these two fractions, dividing by this one. And when you're dividing by a fraction, you're multiplying it by the flipped version of the fraction. Here. Then you simplify it, cross out everything that crosses out, and you get this as the final answer. I don't think I have to explain much here because x cancels out. Then y to the power of 3 minus 2 is equal to y to the power of 1. And for z just stays. And then 3 cancels out, 4 cancels out, and 2 and 5 stay. Cannot simplify that further. Statement C, another honestly masterpiece of a statement, because here x minus 1, how beautiful, and y minus x are different. So if you see, it is the difference of squares. It's the same thing as this, essentially, the lower part. One second. Yeah, basically, if you don't pick one of the right options, you just get 0 points. If you pick one of the wrong options, you get minus points. But please wait until Wu publishes the full calculation procedure. Yeah, exactly. But again, they can weigh them differently. A positive answer can weigh more than a negative answer. Please wait. Like, okay, like guessing is not ideal, right? We should really think about it or leave it blank. But let's wait until but because you also lose points if you leave a correct option blank. Yes, it would be better to not, but some what is actually nice? Like this is not as bad as you might think it is. There was a differentiation task that's much more annoying than this, or the language probability task that's much more annoying than this to solve. Yes, there is. You can't go lower than 0. Correct. Also, I know that in the one of the info sessions it said it's like more or less the same points per part, but they have also said that in 2025 or 24, and then it still stayed 40% economics, 21% English, and 39% mathematics, even after the program coordinator said that, hey, it's more or less equal. So you will see the number of points next to each question, and you can go from there. I would say wait until the exam day. And here, to basically have the common denominator, you're just adding what you're missing. But again, but English is also, I like it. I like the fact that it's a bit less because then it tests your economics and math skills more because English, they assume you have it anyway because they ask you for the Matura or for the IELTS or TOEFL exam. Okay, let's get back to solving because otherwise you won't have enough time. So here, 1 plus x and x plus 1 doesn't matter. You just multiply it by x minus 1. Here you multiply it by x plus 1. And here you multiply it by minus x plus 1. So minus 1 times. Because you want to change the order from 1 minus x to x minus 1. That's why you have minus 1 times x plus 1 as the multiplier here. This is a very common mistake. It's very easy to make if you're in a rush. Once you do that, you'll get this basically. Once you also look at all the signs with the minus or with the plus, because here, yes? So yeah, here you had a minus, but you had a minus as well. So in this part, this minus and this minus cancel each other out. And cancel, but it becomes a plus. So you essentially get this. It's just like the final result, not to write out a huge line. And then as a final thing, you get this. And you can say, okay, this you can get 4 out, x plus 1. And this you know what it is equal to. It's x minus 1, x plus 1. And since you know that x cannot equal to plus minus 1, you can cancel this out. Otherwise, you wouldn't be able to do that. And that's how you get 4 over x minus 1 as the final result of simplifying all of this and solving. So the left side is equal to the right side. That is true. Statement D is kind of very obviously false because here you would have multiplication xy and not x plus y. So if you can see it, you don't solve it, just go for it and say it's false. Because in one of the interviews I did with Max, so he got 12th place on the exam in his year, and he became the top of his cohort, and yeah, he's going to Cambridge, I think, for masters. So a very smart young man. And he told that, okay, it was more true for the online exam, that you shouldn't, if you can calculate something in your mind or you can see something clearly, if it's true or false, just cross it and move on. Because again, 2 hours, not a lot of time. But this advice has there's two sides. It's either you know it and you save some time for the rest of the tasks, or you rush and then you get a really easy mistake that you could have easily avoided by just calculating it further. So be careful here, but yeah. Here it's kind of obvious because to get the common denominator, you have to multiply them by each other, not add them to each other. I hope everyone knows this rule. So yeah, that would be false. And in statement E, again, you have the difference of squares just in a different format. So it's basically this. And then you can also write it like this, really up to you how you write it, because it's the same thing as 4 over x squared is equal to 2 divided by x squared. Different representations. Some just look a bit neater. Whatever you prefer, go for it. So yeah, that's how you have this and not that. So that's what makes it false. So you have 4 over x squared minus 1 as the final answer, and not this as the final answer that they stated in the statement. And that's why it is not correct. So seeing the difference of squares or seeing the common denominators and seeing how you can simplify a fraction is really useful for this task for elementary algebra. But yes, in 2023, it was much harder. It was a bunch of inequalities there. And now they have separated elementary algebra into inequalities and equations, like 2 subtopics of it. So you have quite a lot of potential there for annoying things. As I mentioned, equations. It looks like a lot of text. It looks like no way you can solve it, but actually it's very nice. Yeah, don't need the camera. And yeah, let's go for it. And here again, out of attention traps, as always. Cannot really avoid those. We have a rectangle, right? And one of the sides is 3 centimeters longer than the other side, and the area is 40 centimeters. So the length of the longer side is 5. If it helps you to draw the thing, draw it. If you don't need to, don't. But if you like it, it's just basically like this. This is the longer side. This is the shorter side. The areas you multiply the side by the side. And then you get the parabola, then you can get the discriminant, you move everything to one side, get the roots, la 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 la. And then you get a negative and a positive root. Of course, you pick the positive root because the length of a side can be negative. So the short side is 5 and the long side is 8. Because the long side is 5 plus 3, because x is 5. And then for statement B, a car travels at an average speed of 64 kilometers per hour. At 3 p.m., it has traveled to a distance of 112 kilometers. Therefore, if this is the case, it started traveling at 1:15. So let's see. And with hours, it's super annoying just to keep the minutes and the fractions and all those intact. So here we have the average, the distance. At the average speed, we get the time. So it traveled for 1.75 hours. In other words, 1 hour and 3/4 of an hour, which is 1 hour 45 minutes, because 45 minutes is 3/4 of an hour. And at 3 p.m., so let's look at our start time. So if it's 3 p.m. is the end time, and we have traveled for 1 hour and 45 minutes, then our start time must have been 1:15. Here, just careful with minutes and hours. A double check, 15 minutes plus 45 gives you 2 p.m. plus 1 gives you 3 p.m. In case you're not sure, you can reverse it and see if it matches. For statement C, a recipe, okay, see a question in the chat. So this is one-to-one task from 2025. This is the recent year. This is the most recent year. So here we go. They might then make them the same, like they make them a bit easier, a bit more difficult, but overall it equals itself out. We have some easy tasks, we have some hard tasks every year. Of course, if they want to make harder tasks, they can, but this is the most recent information from WU officially published on their website. It seems easy, right? Doesn't seem so difficult now when you have the solutions right in front of you. Because imagine you have 2 hours, you're sitting with thousands of people around you, and then it feels a bit different because now you're at the comfort of your own home. You don't have the time pressure, you don't have the stress pressure, no people around you. Of course, it will feel a bit not as stressed. And it's more for also a time exam. The tasks themselves are very much doable. They're fine. It's the time that gets you, because 2 hours for all of this, for all 3 parts, if you're like under all these conditions with not the best calculator, like it's a like simple scientific one, then this is the time gets eaten up. So to get a very high score, you need to solve and solve and solve without stopping too much. Yeah. So a recipe calls for 5% vinegar. If the cook has only 1 liter of 8% vinegar, and then he needs to mix it with some kind of water, let's say 0.6 liters, that's true or false, to get the right concentration. So from a concentration from 8%, you want to go down to 5%. So yeah, here we have the concentrate on the top. So 0.08 liters would be pure vinegar out of 1 liter because you have 8% of it in the liter. And below you have the 1 liter that you have plus some volume of water that you don't know yet what it has to be, but you can find it out. Yeah, no, they will not really tell us. Yeah, yeah. Of course, they will change the questions. Like they will test more or less the same skills, but questions will be different. That's why I'm guessing, like, if they haven't released some of the tasks, like the remaining ones, maybe they will make them the same. I don't know. Let's see for the ones that I haven't published, because there are 13 of them, not 8. So yeah, here we have liters of water. So the total volume of the liquid and the concentrate on top. And then you see, okay, how many liters of water do you need to add to go from 8% to 5%? And at 0.6, you just solve for V here with the cross multiplication rule. Like this. And this one, again, amazing equation, I would say. Here you immediately have to see that these are all powers of x. And what you can do with powers is you can put them in front of the logarithm. For statements like C, yes, there is a formula. If you just look up like concentration tasks or like mixture tasks, you will find it. There is theory behind this, but here I'm just explaining the tasks because otherwise it's going to be like a 5-hour lesson. So here we notice that this is the same thing as x to the power of 1/3. This is the same thing, of course, okay, logarithm, yes. Log is just log in our case is LG. This is the logarithm of the base of 10. And then we have log x to the power of -3. Minus, and here we just keep it the same, log x2 plus 16/3 is equal to this. And this part is just log 10 of 100 gives you 2. This is 2, so 1 plus 2 is equal to 3. And here we keep the logarithm. So now then we put the power in front. This is a property. So that's why when you know the properties and the formulas and the rules very well, you can immediately see which one of them you should apply and how you should apply it. So it's a mixture of knowing all the theory and knowing the tasks. So here you have 1/3 in front, then here you have -3 goes in front, and here you have 2 goes in front, but the minus was here. So essentially you have 1/3 logarithm of x minus 3 log x minus 2 log x plus 16/3. This is the left side. Then these are all log of x. You can combine them together. So basically, if you want to multiply it by 3, it's the same thing as -9 and -6. So -14. Because this is -15. And this is +1. Ah, yes, I will publish it I will publish it like openly on YouTube so everyone can see. So yeah, that's how you get this final left side simplification. The right side, we've discussed denominator is equal to 3, and here you can just put 2 in front of the logarithm using the same rule. And that's how you get this part. So 2/3 basically, it's like 2 divided by 3 times log x, just written in a nicer way, where you put log below and the fraction by itself. Same thing as log x divided by 3. Just in my mind, just a bit better, like easier to see for this part. Then you simplify them further. So these are just intermediate steps I will skip. You multiply them by 3, and then you eventually get 16 is equal to 16 log x, and log x is equal to 1. So logarithm with the base of 10 of x is equal to 1. So this to the power of that is equal to x. So 10 to the power of 1 should be equal to x using logarithmic properties. Therefore, x is 2. It's not smaller than 5. Therefore, it's false. For statement E, oops. A prize of 12,200 euros is supposed to be split among the winners. Second place gets 80% of the first place, and third place gets 80% of the second place. And then you want the price for the second place. Is it 4 or not? 4,000 or not? So, okay, first place price is, let's say, 80 euros, whatever you want. Second place is 20% less, so like it's 80% of the initial price for the first place. And third place, it's 80% of the second place. And because we know the second place is 0.8 A, and if we do 80% further, we get this. So the price of the first place, second place, and third place in terms of A, we solve for A, we get A is 5,000, but this is the price of the first place. To get the second place, you multiply the 5,000 by 0.8 to get 4,000, and that's correct. Here, common mistake would be just to see 5,000 and say it's false, but you actually have to then do one little more, like one more calculation and multiply 5,000 by 0.8. Now task 4, so we will be halfway done. If you have questions as we go, please feel free to ask them in the chat or by unmuting yourself. And you can also be able to ask them in the comments on YouTube in case you want to kind of chat later. Here we have, it's actually the first time that they ask something like this for the linear equations and unknowns. Usually it's 2 companies or 2 pizzerias or something like, or pizza 1, pizza 2, quantity 1, quantity 2. This is a bit more creative. And it's like work productivity task. There's also formulas for this specific subtopic. It's called like your productivity task, like work per hour tasks. You can also find it online if you want more theory, but here we're discussing the task itself. So here, let the total work be one order, no matter like be it 100 cookies, 200 purses, whatever it is. We don't need to know. So it's one job. It's one order that it's made. We know that Frank and Julia, if they have had worked together the entire time, they need 6 hours. So for one order, Frank and Julia need 6. Job per hour formula, just job divided by the hour. So one job divided by 6. So 1/6 plus 1/6 plus 1/6, like per hour, what you're doing, 1/6 of the job. If you do it 6 times, you get one job. Yeah, that makes sense. Then Julia, here we know that they worked together for 3 hours. So they finished half of an order. I will, yeah. If basically this was half of an order, and then Julia had to work another 5 hours to finish the other half. So she finishes half of the order in 5 hours, meaning that she would need 10 hours to finish the entire order. And Frank, we don't know his productivity, so it's like one job over X. But what we know is that the productivity of both of them combined is equal to 1/6. So if we add 1/10 plus 1 over X, we get 1/6. And you can solve for X. So Frank, it actually takes 15 hours. Frank is a bit slower than Julia. So for one whole job, if he had to do it by himself, he would need 15 hours. After you figure out this part, it takes you a bit more time, but then you can solve all the rest of the statements pretty easily. So sometimes on the exam, it's worth to invest like 2 or 3 minutes into like the beginning to then solve everything in like 30 seconds per statement. So don't be afraid if something is taking you too long. At first, it usually gets easier as you find more and more things. So yeah, Frank only takes 15 hours. We just found it out. And then for statement B, if the order was 150 purses, then the difference between the times Frank and Julia need to assemble one purse is more than 3 minutes. So we're just comparing how fast Julia and how fast Frank assemble the purses. You have the Frank's rate, so you have 150 times the productivity of Frank, and 150 times the productivity of Julia, 110. So she does 15 purses per hour, he does 10 purses per hour, time per purse is 1/10 or 1/15, and 6 and 4 minutes. So difference is 2 minutes and not more than 3 minutes, therefore it is false. Yeah. Because yeah. Even if you do 10 purses per hour, it means you do one purse in 6 minutes, 60 minutes. If you do 15 purses per hour, that means you do one purse in 4 minutes. I think that's pretty clear. Then for statement C, if it's reversed, so that the Julia would feel sick and left after 3 hours, Frank would need more than 10 hours to finish the order. So here we have the reverse situation. They have done together with the 3 hours that they had 1/2 of the order. The remaining half is done. If Frank needs to do half of the order with his productivity 1/15, he needs 7.5 hours, not more than 10. That's less than 10, therefore the statement is false. Because now you divide the job, but you only do 1/2 of the job, and the productivity rate is still the same. It doesn't change. It's 1/15. So you get 7.5 hours. For statement D, if the order were twice as big as the original one, Julia would need 10 hours to finish the order after Frank left due to sickness. So let's say instead of having one order, we have two orders. I think that's just like also in my head, it just works a bit better. This way I like to explain it. So, order twice as big, there is a total work of two. So two jobs, basically, two orders. Together, they work for 3 hours. So they did half of the normal order. So they did like 0.5 together. Therefore, they have one full order and 0.5 of the remaining order left to get to produce the two orders. And Julia is doing it alone, so she needs to do 1.5 of a job with her productivity 1/10. So she needs 15 hours, not 10. You can do it in other ways. You can do, okay, 5 hours to finish the first half because you know Julia's productivity. You know that she takes 10 hours to finish one whole order alone, and she takes therefore 5 hours to finish 1/2 of an order alone. So you do 10 hours for one new order, like the whole one, like plus one, and 5 hours for the half that was remaining when we did the other half with Frank. Then statement E. If they had completed the entire order together, Frank would have completed 40% of the order. Let's see. So they worked together for 6 hours to finish one full order themselves. And Frank's productivity is 1/15 of the total time. So it's 0.4, 40%. Should be the percentage sign, I will change it. So if the order was 100 units, Frank would make 40 of them, Julie will make 60 of them. Because her productivity is just more, she's faster. Then task 5, inequalities. Please, if you have questions, just ask, because otherwise I'm assuming everything is clear. A lot of text, but it is easier compared to 2023, as Philip said. So yeah, like the text just becomes very nice, linear equations or parabola at most. Okay, this one is a bit annoying, but the rest of them are fine. So within the questions, you can say, okay, I will do A, B, C, and D. I know how to do them. Statement E, I will come back to later. You can put like a little star or question mark there because this will take you more time than the other ones. So here we have a farmer is placing in the field. He has 80 meters of fencing available, so the perimeter has to be 80 meters because otherwise he runs out. And he wants the field area to be at least 48 meters squared. And to maintain the ratio of 3:1 between the longer and the shorter side of the field. Then with all of this given, what you have to check if it's true or false, that the shorter side can be between 4 and 20 meters long. So here we have let's say the shorter side is A, the longer side is 3A to have the ratio 1 to 3, right? This is just like in a bit simpler terms, like 1 to 3. Perimeter has to be less or equal to 80 because that's how many meters of fence he has. So 8A, because if you do the rectangle with A, 3A, and 3A, you have 8A together. It's 10, so the shorter side is less or equal to 10. And the area has to be when you're multiplying 3A times A, 3A squared, greater or equal to 48. You solve for A. You obviously choose the positive answer here because you cannot have a negative side of the length of the field. And thus the thingy, because this is a system of equations of inequalities, has to be between 10 and 4. So less than 10, but greater than 4, the shorter side. Then, if the position of an object above ground in meters after X seconds is described by the basically this is how you throw the ball or whatever it is, and it goes wing, because like I said, it goes up and it goes down. And you want it's a concave parabola, it's more than 100 meters above the ground, so at some point this is 123 meters, and you're trying to see the time when it was 123 meters above the ground. That's what you're trying to, what's the, how to say, the picture here, what you're trying to solve in graph terms. If it helps you to draw this, draw it, not to confuse. But in other words, you can just do it with equations. So here you want this parabola to be greater than 123 meters because you want above 123 meters, not above or equal to 123 meters. And then you solve the parabola. You move everything to one side, divide by -5, switch the inequality sign because you're dividing by a negative number, and then you get the final answer between 2 and 12. And be careful, like this is the final thing that you're solving. Like even though it's very different from here, you got to this part by making this look nice. By getting to one side and everything. So this is the final thing that you're gonna be looking at for your final answer. Not whatever happened here. Then C is the average cost per unit. So if the cost of producing X units of a product are 150 plus 0.2X, yeah, no. Between 2 and 12, don't include. Here, they're not very strict with the definition. So then to keep the average costs, if you want, you can plug in numbers, yes. Takes a bit more time. I think it takes a bit more time in this case to do it with the plug-in numbers, but why not? If you want to, I'm not prohibiting it. Then here, if the cost of producing X units of product are 150 plus 0.2X, at least 83 units must be produced for the average cost to be below 2 euros. And of course, you can only produce whole units. You can't produce like a 0.5 of something. Or 0.5 of the t-shirt would look not very nice. And then here, let's say, the average cost below 2 euros. So you just want to take the cost function, divide by X to get the average cost, and it has to be below 2. And you just have to solve this to find it. You solve for X, and you find that X has to be greater than 8.333. Therefore, the next closest integer that would make sense would be 84. Because at least 83 includes 83. If you produce 83, you have the average cost of more than 2. Here you can also just plug in number 83 and see what happens. Yeah, as an option. I'm just only like also like how I think how they intended it to be solved. So yeah, therefore the average cost of 83 would be more than 2. The next best unit is 84. It's kind of the answer is in between, but you cannot have non-whole units, so that's why we pick 84. So it's really this close because it's kind of 83.333. If you're rounding it up based on mathematical logic, it's closer to 83. But if you're doing it based on the production logic of a company who's producing units, like whole units, it has to be like 84, not at least 83. Then for statement D, it looks super long. Don't worry, it's not that bad. To produce 1 unit of a certain product, there are 3 raw materials, A, B, C. You need 3 materials of A, 2 units of B, and 4 units of C. And the raw materials cost 40, 15 to 25 respectively. So respectively just means this is A, this is B, and this is C. We also know that the production of 1 unit of the product costs 12 euros. So like labor and machinery used. And the producer has a total budget of 21,400 euros. Yeah, it's up to them. They can make them harder. It's really up to them. Because it's like the examinators who are making the tasks. And if they want to make new tasks, they can. Could be easier, could be harder. They're just changing the theme. Like it's either just inequalities with like normal mathematical terms, like here in statement E, or in text. It's up to them what they want to choose. As you can see, they just mixed in a bunch of things here. Text and the inequalities. So here we have the total materials per product. It's 8 units because we also have the storage capacity. So you can have the budget of 21,400 euros and storage capacity for at most 475 units of all raw materials combined. Then, if you have all these conditions, the maximum number of products that can be produced is less than 50. So let's see. You have the raw materials per product is 9 units. And the storage is like, so 9 units. So how many products you can store? Less or equal to 475 is less or equal to 52. Then the cost per product in raw materials, you have 3 units of 40 euros, 2 units of 50 euros, and 4 units of 25 euros. So these are the costs in raw materials, and you have the production costs being 12 euros. So the total cost per unit is 332. Yeah, exactly. Yeah, good point, Philip. Then the budget is basically, well, the total times the units that you want to produce of one whole product, not the raw material, but the whole product, because one product needs 9 units of raw materials, and this is the cost. So this is the end for the budget. So 64 units of products is fine with the budget that we have. But basically, we have the maximum storage of 52. So the maximum that you can produce is not less than 50. We're actually pushing it because we're over the maximum, but we have the storage limit. So the closest we can get from 64 up until the storage limit is 52, and 52 is not less than 50, therefore the limit is false. It's more than 50. It's actually 52 exactly. Like we are filling up the capacity to the maximum. Then statement E, we just want to see the if and only if this, so if the solution of these is satisfied if and only if the absolute value of x is greater than 2. Let's see. This is a double inequality, which we can just put into a system of 2 with the end bracket. So this is the end bracket. This is the or bracket. So yeah, union and intersection, so to say. So this is intersection of the intervals, and this is the union of the intervals. So let's start. This is pretty nice and simple. And this is also as well. So here we just to one side, get the common denominator, like simple transformations, I think you know. And for the absolute value, it's either it's greater than x or less or equal to minus x. Because if we want something, oops, to be greater than x on the interval, it's either greater than x, right? So it's greater, or less than minus x, because the absolute value, let's say if this is 5 and this is minus 10, is less than minus 5. Then you would still get the absolute value 10 being greater than 5, it will still work. So that's why you have either this or this possibilities for the absolute value. And of course, there are like a lot of formulas for the absolute values that you can memorize. You can also learn how to understand them, and then you don't have to recall the full formula. You can just like write this just from understanding what the absolute value does. Then you solve, and basically you get the solution set being between -2 and 0 and to infinity. And it's not equivalent to this because this would give you either over 2 or less than 2. This is what's this part. And this thingy that you actually solved for, it goes from, where is 0? Around here. -2 to 0, and then 2 and above. So yeah, it doesn't go below -2. It stops there. So if they're not equivalent solutions, solution sets, therefore statement is false. Power functions, this is a very nice, relatively easy task to do. So here you have a production function, W of L, so the wheat output of labor is 0.25 L to the power of R. This low-key reminds you of the Cobb-Douglas production function. I'll do on macroeconomics a bit later. And then to produce 4 kilograms of wheat, the farmer needs to work for 32 hours. So we immediately see that after 32 labor hours, we get 4 kilograms of wheat. This is one point that we can use to find the R that's missing. We know that it's a real number. And of course, therefore, L cannot be negative now because work hours can be negative work hours. So by doing that, we can solve with this 1 point the function itself. And we can find out that R is equal to 0.8. So like these small math tasks, I'm just honestly going to be skipping because I'm assuming people are familiar with elementary algebra rules. And if you want to take it a bit slower at home by yourself, you can time yourself and see if it takes you it should take you anywhere between 4 to 6 minutes to solve a task. On your own with a calculator that's allowed and pen and paper. But here I'm just discussing an answer. So yes, R is greater than 0.5. And then B is a nice statement where we just say, okay, if we are working for 64 hours, we have more than 8 kilograms of wheat. So we plug in 64 would be, we have our R small 0.8, we have everything, and we see that we actually are producing over 8 kilograms of wheat, we are producing a bit less than that. So it's false. And then this is a messed up way of asking you to know how the function looks like. This is a power function with a power between 0 and 1. With a positive beginning value. Even if it's less than 1, it's still positive, it's still okay. And here we have L1, and here we have L2. So here, the marginal increase in labor the marginal increase in anything is just the first derivative, and the first derivative is the slope of the tangent line. Here and here. Here it is flat, like flatter. And this is steeper compared to the other thing. So assume that for Ben's neighbor, the reproduction function is the same. If Ben works L1 hours, then Ben's increase in production from additional hour of labor is greater than the neighbor's increase when working additional hour. Yes, because if like Ben does it here, he is more productive here when he goes a bit up. But since for neighbor for L2, if you go up one more, you're already super tired. It's like physical work. You're going to be working for 1 more hour, but that 1 hour is going to be less productive than the beginning hours. It also makes sense in real life terms. You can also build the marginal product function with the first derivative, see it's decreasing in L, so it's going to be like the first derivative is decreasing. It makes sense because the slope gets like less and less and less steep. On the exam, you can just put your pencil next to the graph and see how it behaves because the first derivative is just the value of the tangent to the graph. So it's true. Then for D, we're just trying to solve for a function of L. Marginal product is the slope of the tangent line because marginal is the first derivative, and marginal something is the slope of the tangent line that gives you the first derivative. Then this part, the amount of labor necessary for a given width output is the power function too. So we're going to be switching W and L sides. So here we have the original function, and now we want to transform it for L. So L stays, then you have W over 0.25, same thing as for W. And then you take the root of 0.8 of both sides. So get L is the root of 0.8 of 4W, and that's a power function actually. The same thing as to the power of 1 over 0.8, because this is 1, goes up, this is the root power, goes down in the fraction. So yeah, it fits this description. It's a constant times x to some power. Now W is our x, it's our independent variable instead of L. Then to double the output of the width, so to double the width output, the amount of labor must be more than doubled. True. There is this way where you put two W's here into this function and you solve for A, but I don't like this way. Like, it's kind of the mathematical way with the labor out of width. I prefer to do the plug-in numbers way here, so I will explain that one. The minimum for 2025 was 86.8. Now it should fall with the same and fair conditions for everyone, less people participating, and also negative point system. I would assume it's between 75 to 80 something. I think it's gonna fall. So what I like to do here is, okay, in 33 hours we produce 4 kilograms of wheat. How many hours do we need to produce 8 kilograms of wheat? That's the simplest thing to do here. And then so we solve basically the function for 8. What is this? I think it's a typo in LaTeX code. Like 0.25. Yeah, it's the power. Every time it's like this is equal to 8. Because when you do the power in LaTeX and you don't do the small brackets, it makes the second thingy go down. And then you solve for L. So L 0.8 is equal to 8 over 0.25. And therefore L is equal to the root of 0.8 of 8 of 0.25. And it is 76 point something. And if you compare the L new with the old L, it's more than doubling the time, yes. Because 76 hours is more than double of 32 hours. It's also pretty visible even without dividing them by each other. As you can see here, the majority of the statements are actually correct. Here we're almost done. If you have questions about the tasks, please ask, because I see you have a lot of general questions. But if you have questions about the task, also feel free to ask me. I just need just in case. Perfect. So denoted by FT, the population of the country. So the current population is 10 millions, and it is assumed that it grows by 1.2% per year. Okay, this one, it's rage bait again. This should be 10 million, not 10. Like everything is correct here with the growth rate and everything, but it's just it should be 10 million, not 10. Great thing here, honestly. Would move. Because you see 10 million and you think it's 10, but it should be 10 like with 6 zeros after it. Then yeah. After 30 years, the population had grown more by 50, will have grown by more than 50%. So here we have 30 years have passed. Here we have our 10 to the power of 7. This is our 10 million. We have 7 zeros here. And then this is just the growth rate. Like we actually didn't really care about this one. We only care about what this does to this number. And then it gives us a growth of around 43%, which is less than 50%. Yeah. So it should be either, it should actually, if it's like this, it will be correct here, but it's not. Then statement C. The head economist of the country predicts that the GDP of the country grows by 4% per year. So then the GDP per capita is basically divide GDP by the population. So I have a little concept from economics. And then grows by more than 3% per year. Let's see. False. Honestly, it's like sounds a bit too big. Like just logically, like intuitively, it sounds a bit too much. So it's more likely to be false than true, even if you don't have enough time to solve it. But if you do, you just divide the growth factor of the GDP by the growth factor of the population, which is like 1.2%. And you see the total growth of GDP per capita, because GDP is population. So it is around 2.78%, something like that, which is less than 3%. Then assume that after 5 years, the growth slows down to 1% per year. Then the population of 12 millions will be attained at t greater than 15. So here we have after 5 years it slows down. So before that, it was fine. Before it was a 1.2%, and this was like until like year 5, this was the case. Then we take this as our again value, and we keep increasing it for the remaining years, some years that are still left, but now it's the growth, the population growth is 1%, 1.2%. So down to 1% means from 1.2% to 1%. Also be careful with percentages, with increase by, slow down to, some value of, or percentage points, because then it differs what kind of percentage you're applying. Actually, in one of the previous years, they have also select percentage points. So just to kind of, just in case it comes up again. So if I say that I have 5% and I increase by 20%, that means I increase 5 by 1/5 of 5, so I get 6%. If I increase it by 20 percentage points, I get 25%, not 6%. So be careful with the wording. Just a little side note here. And then you're basically trying to solve how many years it takes to get to 12 million. This is 12 million, just written with a nice factor. And you solve for t using ln. Using ln because you can only pick LG or ln on a calculator, you can't really pick the base. So you pick ln or LG as a way to solve it because you're just taking ln of both sides. T goes in front, and then you're dividing ln of this number by whatever this was in the case. So this number divided by ln of this gives you 12.32 years, and then you had the remaining of the other 5. So 5 plus 12.32 gives you 17 years and something, which is already more than 15. Therefore, it's true. You need more than 15 years to get to 12 million people. Then the last statement is about the continuous rate growth. So you have 8 million, whatever this doesn't matter. Like this is the beginning value. It plays no role in the growth rate. Then the growth rate of the neighboring country is smaller than 2% per year. This is a continuous growth rate of 2%. A continuous growth rate of 2%, if you want to do it in discrete terms, it would be actually 2.02. Because if you're going from continuous to discrete, e to the power of k is your a small. So e to the power 0.02 is your a, that gives you the discrete growth per year, and that is a bit more than 2.02% growth in growth terms. I actually calculate this very quickly on the calculator for you to show you. So it is around in discrete terms. So here you have only one correct statement. Statement D. Before in the previous year, it ranged around from 78 to 82 or something. Then the last task for today, binomial distribution. And we will be done in 1.5 hours, more or less as I planned, because I knew for sure it's going to take more than 1 hour. And right now, honestly, when I'm explaining this, I'm like, my head is like, ooh, because I gave 2 group lessons already before that. You had to work before. So this is like the final lesson for the day. Thank you for spending your weekend evening with me. This is the answer sheet from basically the math tasks that Wu has published. But yeah, these tasks, binomial, it's at the end of the exam. Amazing task, super easy to solve, takes you so much less time compared to differentiation or something else. That's why I advise to start with these. Like you can go from the lower tasks to the upper tasks. Amazing idea. And then for long-term observation, it has been calculated that a tennis player wins on average 17 out of 25 games. Amazing. That's it. That's all you like. No text. Great. And here you have the probability of winning a game is, well, on average, how many he wins by how many games are in total. The probability of losing is the opposite of that. So it's 1 that we just found. And binomial distribution, you have to have just 2 outcomes. And then they have to be independent of one another. Sometimes you might think that there is an experiment, say like throwing a die, you have 6 outcomes, 1, 2, 3, 4, 5, 6. But if you phrase it in a way like even or odd number, or 5 or not 5, then you can make a discrete probability, like an elementary probability task binomial, depending on the context, like how it's asked. So probability to lose next game. So here all the games are independent. So it's binomial, like it says that here, binomial distribution, right? The name. So the binomial distribution properties apply. The probability of losing or winning any game in any order, whatever, 10th game, 20th game, first game is 0.32. It's true. That's what we just found here. The expected wins in a game is the expectation value. In binomial distribution, just n times p. In elementary probability, the expectation value is a bit more complex than that. You have the sum of the probability, times but this is for elementary probability. For here, for exponential, for binomial distribution, it's just n times p. Great, it is 8.16, not 4.8. And here the expected value is not something that comes up in 50% of the outcome. It's just something you might expect. It doesn't even have to be a whole number to make sense here, just like a calculation-based thingy. Like you expect around like 8 or like 7 or 9 games to be won, but again, this doesn't have to be exactly number, and it doesn't have to make exact sense, or it doesn't have to be something that happens in 50% of the times. It's not the definition of expectation value. Then the variance, you just multiply it all by each other. That's the formula for variance. And standard deviation, if you're ever asked, so just sigma, because this is sigma squared for variance, would be the square root of variance, in case you ask you that. Just, yeah, my spelling is amazing, but yeah, I guess I know what you mean. So you multiply the n times the probability of winning times the probability of losing. Then the probability of winning next 3 games in a row. So you want game 1 and game 2 and game 3 to be 1. So you multiply winning times winning times winning. Because when you say and in elementary probability rules, you would usually multiply. Of course, you have to be careful what you multiply, if it's dependent or independent events. But in general, just multiplying. And then the last one the probability that the player wins at most 4 out of the next 6 games is more than 0.6. So at most 4. So either 0 game wins, 1, 2, 3, or 4 wins. This is when using the complementary event rule makes a lot of sense because you want at most 4 to be 1. This is what you want. This is what you don't want. So 1 minus what you don't want will give you what you want because the probabilities of all events and probability distribution have to add up to 1. And this is just a bit faster to, instead of adding up 5 numbers, you're just doing 1 minus 2 numbers, okay, fine. And the way the binomial distribution formula works is you do nk, p to the power of k, 1 minus p to the power of n minus k, and then out of 6, choose 5 games. The probability of winning times 5 because you want to win 5 times. The probability of losing, the opposite one. And then losing and winning all 6 would be just 6 out of 6 would be 1. Probability of winning 6 and 1 minus p to the power of 0. So this becomes 1. This also becomes 1. You don't have to write it. Yeah. And please, this is not vectors because some people say it's vectors. This is binomial coefficient. And it can be calculated on your calculators. There is a button for it. 1 second, I'll tell you what it is. In my calculator, it would be NR. This is for combinations when the order doesn't matter. For permutations, it would be P and R, and the formula changes slightly. You can look it up for combinatorics in case you're interested. But here we're using combinations for binomial. And this is permutations, where the order matters. But yeah. As you can see, you have to be careful with rounding because it is only slightly more than 0.6, and that makes the same true. So please don't cut down, like don't round them up too much, because otherwise you might get drunk, even if you're working out as right. Because on the exams at WU, when you have open questions, if they see that you're working out as right, but your rounding is wrong, they will still give you partial points for knowing the solution. On the exam as multiple choice, no workings out will be graded. So it's either true or false, and you get it right or wrong, or correct and correct. I would assume this would be it from my side for today. Do you have any questions you would like to ask me?
No.
Perfect. And I'll answer this question in chat. And another thing, I will publish all the tasks here in the blog of my website. And you will find them as the latest post as a PDF file, because in YouTube I cannot attach a PDF file to the description. You're welcome. And this year the time was reduced, but the reason behind reducing the time is because you don't have to have the annoying mouse with you to solve stuff. Now you have a pen and paper, which arguably makes you solve it faster. So I don't think they will decrease the number of tasks. And usually, yes, they have 1 question per math topic, so 13 math questions. Yes, you'll have 13 tasks. And I see someone rolls their hand. Daria? Okay, I see now. So yes, don't think that they will make it nice. Like I've never seen Wu make it nicer, like in the history of it. So yeah, that's why you should expect around 10 economic tasks, 10 English tasks, and 30 math tasks as usual, with 5 statements each. And for math, it's 1 question per topic. Makes sense. And Daria, what's your question?
So for the multiple choice questions, they won't say if one answer is like only one answer is correct. They will all basically just be, or they specify whether the question only has 1 answer correct or any answer can be correct.
They will just say at least 1 is correct. That's it.
Great, thank you.
Welcome. They don't give you too many hints, unfortunately. Then thank you so much. You will see the recording of it soon on YouTube, and the tasks will be published in the blog. You can get it doesn't matter what kind of pen it is. You can bring any pen that writes. Bring a few pens with you, like a blue and a black one, just in case. If you have a lucky pen at home, feel free to bring it. And yeah, and there is no difference. Okay, then I'll give people just 1 more minute to ask any questions that they might have. And if you're wondering for the YouTube channel link, just DM me later, either on Instagram or an email or via the website. It's up to you. So you can find me on Insta in case someone doesn't know. But I mean, I think most of you have seen the stories on Insta. No, it's pen. No, Philip, don't do this. Only pens are allowed. Or email if you would prefer to contact with me. Email. Yeah, Philip tried to undermine the competition. Didn't work. And then yeah. And website in case you wanna check out the post later. Blog. Perfect. These are all the contact details. The video will be okay. Thank you. Okay, sorry. I thought you were mad at me for saying that pencils. Okay, thank you. So yeah, like here we had around 80 participants, and technically will get in. Please study. Please give it your all. 1.5 months. It's worth a shot for sure. Because BBE so far, when I was comparing it to like TU Leuven, to Bocconi, to other universities in Austria, and yeah, I would say it's one of the best combinations of everything, price-wise, quality-wise, professors-wise, and location-wise, and campus-wise. Thank you so much for appreciating. Thank you for I think it doesn't matter, but please bring one of each just in case. Blue, but I don't remember. I think it could be whatever color. So yeah, thank you so much. Thank you for the directions, and I'll probably see you in another open lesson because I'm hosting at least one more in June, open offline and online as well. Welcome. Ciao, ciao. Thank you for the hearts. It's so cute. Thank you.